Alright, welcome to the lunchtime video. Unfortunately yesterday I skipped the after work video, but I did do 2 weekend videos, so things are going pretty good. I can definitely do a after work video today. I hope I'm not speaking too soon about that, but okay, so I configured all of the routers, so the next step is going to be going through and making sure that they work. We've got a bit of an unusual configuration. We've got an autonomous system here, and I'll just call it autonomous system A. And we also have 2 more autonomous systems in this topology for a total of 3. There's a Harrier. Oh, there's like a really noisy helicopter coming over. All right, so now what I thought we would get is autonomous system A, B, C, and then CBA, but what we're actually getting is ABB, CCA, which I was definitely not expecting, and I'm a little bit skeptical that it will actually work that way, but the intent of this video, this lunchtime video, is to do pure troubleshooting and make sure that this is going to be working. So at the end of it, we should be able to ping end-to-end a loopback from router A to router F. Okay, so we've got BGP on here. Let's start by verifying that it is established. Okay, it appears to be established, but we'll get a cleaner output. Yep, so it's definitely established. Let's move on to the next router. Okay, so now let's verify each eBGP and iBGP. eBGP we know is going to be up because it was established on the other side, but we'll also need to verify iBGP, so I'll run the same command. So yep, we've got BGP through the VPN is up, and then we've also got it core facing. That's up as well. This is going to be the iBGP connection. We know that because it's the loopback address. So let's take a look at the configuration to see what other protocols need to be verified. Okay, so we're also going to need to verify the Rsvp, MPLS, and Ospf adjacencies. Let's do a show Rsvp neighbors. Okay, so those are up. Let's do a show Ospf neighbor. Okay, so we've got a neighbor in full, perfect. So now let's do a show MPLS LSP to see if we've got an LSP to router C. Perfect, so we've got an LSP set up to router C. Everything on this router seems to be good to go. So let's move on and troubleshoot router C. Okay, so we've got similar things to check. We've got a iBGP and an eBGP. We know that the iBGP is going to be up because it was up on the other side, but we can use one command to check both, so we'll recheck that. And yep, it's up. The iBGP is going to be this one down here because it's established to the loopback supernet space. The other connection is a eBGP, so it's established to the actual physical interface on the other side. Both are established, so that is good. Let's check Rsvp neighbors next. So yep, we've got 2 Rsvp neighbors. They are both up. Let's check Ospf. Ospf neighborship is up. We're only going to need one of those, I believe. So let's check the MPLS LSP next. And the MPLS LSP is up. So yeah, everything's good. The reason we only need one Ospf neighbor is because we've got eBGP connection here between router C and D. These are basically the 2 ISPs. So Interprovider means so in our last topology, and let me do my really fun thing that I figured out, and actually I've started to use this more and more. This is just so awesome. So if I go to my bookmarks here and then go down to Login Sketch Together and click Sketch Now, I can get to a sketchpad, and now I can share the sketchpad with my Samsung Galaxy Tab A, and I can draw out any ideas. Oh, I gotta enter in the URL correctly though. It's a pretty short URL, but it can be a lot on a touchpad. Okay, so I made it to the sketchpad, so now I won't have to rely on Microsoft Paint and using the mouse and making awful drawings. You can see everything I draw on my Samsung Galaxy Tab A just shows up right in the browser. So let's think through the topology here. So the first thing I'm going to do is write out the topology we saw in the last exercise. So I'm going to use 3 different colors. I'm going to use red, green, and blue. So red is going to be the customer. So we had 2 customer devices. So the first one we had here, CE1. The second one I'll write down here, CE2. Okay, so we've got 2 customer devices. Another thing we had is an ISP. So I'll write the first ISP in green. So we've got ISP1. Okay, and then we also had ISP1 down here. Now I could go ahead and write out PE, P roles, CE roles, those sort of things. You know what? I think I am going to do that because it's just going to be more clear. So these here, we're gonna call these the P routers, and then we're just going to write out the different kinds of routers that you'll see to make that more clear. So there's the P1 router. You're going to have a connection there, of course, and then there'll be one more router involved in this. Here's we'll call it PE2. Yep, and just like above, and just like above, we're going to have one more router involved in this. It's going to be, now here's where it gets interesting, because the other router is going to be a CE router. So we'll call it CE2, and then here we'll call it CE1. So it's going to have the same name as for the customer, but it's going to be in green. That way we know that it belongs to this first ISP here. So in addition to the first ISP, there is a second ISP here, and that basically just serves as a link to connect the ISPs together. If this customer here were a bank and they had locations in Michigan and Wisconsin, but the ISP only had areas in Michigan and Wisconsin separate, but could not connect to each other. One thing that that you could do is have ISP2 here, and then ISP2 sells a transport connection to the first ISP, and that way the first ISP doesn't have to buy extra expensive equipment to link themselves together. This is a really good thing if, for example, there's a bank with branches all over Wisconsin, but then they just happen to have a one-off branch in Michigan or something. This is something that this is a really good option for an ISP, because there's no sense in just going and building a lot of extra equipment in Michigan just by just pay another provider to connect the two sites together. So this is something that is very common in ISP, clearly as evident by its prominence during in the curriculum of this exam. It's rare that an ISP can just build its own infrastructure to connect any node to any other node. More commonly, ISPs interoperate with each other and do this sort of model where the ISP is both a provider of a service and a customer to another ISP. Okay, but that's what we learned about in the last topic. This new topic is going to be Interprovider. So it's a little bit different from that. There are some similarities. We'll have the same scenario where there's two CE routers connected together from one customer, like a bank or something, and this bank has locations in Michigan and then locations in Wisconsin, what have you, but the ISP doesn't have equipment that connects to itself from Michigan to Wisconsin. It's got to piggyback through another ISP. So similar to that, but the difference between this is this equipment here doesn't exist for that first ISP. So the second ISP will be the ISP that connects directly into CE2. So let's draw that out. So the first part, I'll do exactly as I did in the front, if I may. It looks like I'm having difficulty here. Okay. So we'll do PE1. And this makes sense because it's the provider edge to that customer. Then we'll do ISP1, which is just going to be the P router. And I'm just writing that out because I just want to make it clear that these are two different ISPs. The coloration does that, but okay, so now similarly, we're going to have a CE router here because it's a customer to that second ISP. But now the second ISP is going to be a bit different because it's going to connect directly into that customer instead of back into the first ISP. But just as before, it's going to have two PE routers because it's going to be a provider for both the customer of the first ISP and the first ISP itself. So hopefully this makes it really clear what's going on here and what's the difference between carrier of carrier. So this second ISP is a carrier for the carrier, the first ISP, and interprovider, which is just an interoperation between two providers serving customers that they could not serve themselves if they acted individually. Okay, so yeah, I think that'll make it a bit more clear to understand what's happening here. So let me make sure I don't lose my stylus, lay it back where it belongs. And let's take a look at the Ospf neighbor. So Ospf neighborship is up. So this is router C. So we verified that the BGP neighborships are all up. It's got Rsvp VP Neighbors. It's got a label switch path back to router B. We verified that when we verified router B, but it doesn't hurt to just check it again. And we've got an Ospf neighborship. So let's go ahead and verify the next router, router D. So we know that eBGP neighborship is going to be up, but we'll also need to check the iBGP neighborship. It's going to be configured basically the exact same way as it was on router C. The difference being this is belonging to that second service provider, so it's going to have a different autonomous system, of course, and it's going to have different IP addressing. So really not a lot of differences. Let's take a look at the active configuration. Okay, so active configuration has a, yep, so we've got a label switch path, we've got MPLS, BGP, and Ospf. Let's just verify those. Oh, so it looks like we got problems on this side. We don't have an Rsvp neighbor. We're supposed to have a neighborship to router E. So the first thing I'm going to do is, so I noticed that we don't have family MPLS enabled. Before I check that, I think I will try to ping that other side though, because it's going to depend on that. Oops, and you can see, oh, okay, yep, so the first thing I'm going to do after that verification step, the first configuration I'm going to add is the family MPLS, because that's going to need to get on there eventually, and hopefully it will fix this issue, but even if it doesn't, it's a needed command that is not on there yet. Okay, and I won't need to add it to the interface facing router C. If we go back and look at router C, we'll see that family MPLS is only enabled on one interface. Unless I am mistaken, I could very much be mistaken. Okay, so nope, I'm not mistaken. It's only enabled on the core facing interface, not the interface facing the other provider. So let's make that correction. So the interface facing the other provider is GE000, so okay, so that is, oops, perfect. Okay, so that's good to go. We don't need that extra interface in there. Let's check Rsvp Neighbors again. Oh, so that did not fix the problem. We've still got 0 Rsvp neighbors learned. Okay, so here's the Rsvp configuration. Let's verify that the correct, okay, so it looks like the wrong interface was added to the Rsvp configuration. We're going to need to use the core facing interface, but we use the interface that is facing the other ISP. So easy problems have easy solutions usually. I guess that's not always the case, but in this case it certainly is. Okay, so after I commit this, we should see Rsvp neighbors coming up. So it might take maybe a little bit of time for that to come up. There also could be problems with the other side, so let's just keep that running, and let's go and look at the other side. So the other side isn't going to be router C, it's going to be router E. Okay, and it's going to be the core facing interface on the other side is GE000. Okay, so that has been added there correctly. Oops, it looks like it's missing family MPLS. Let's add that in there. Okay, and hopefully that's all that's needed for an Rsvp neighborship. Aha! Oh, I thought it was working. Nope, still not learned. So let's verify the IP addressing. Aha, so we can see the address on 000. Let's look at the address on 001 on this side. Oh, okay, so yeah, it is compatible. Let's see if they can ping. Okay, so they can ping. So, okay, well, this is getting interesting now. Aha, so here's the problem. You can see, oh, never mind. So I thought I had the interfaces flipped, but that's not the case. Huh. Interesting. Huh. Oh, is this still missing it? I thought I added it. No, it still has it. Or it has it now. Huh. Okay. What if I try a clear Rsvp session all? Huh. That's really unusual. Okay. Okay, so here it looks like I've got a mistake. The interface that is assigned to Rsvf is Ospf is not the core facing interface. It's the interface facing the other ISP. So I do believe an IGP is a prerequisite to Rsvp. So here's the problem right there. I think if I change it, we'll see that coming up. Yep, so one of my prerequisites was not correct, so let's change that and see it come up. Oops, that's interface type. So, oops, so it looks like I'm on, so edit protocols Ospf area, so 0, delete, set. Okay, so we're good to go. Aha, and now the Rsvp interface is up. An IGP is a prerequisite to Rsvp, so if there's errors with the IGP configuration, the Rsvp neighbor will not come up. But that is fixed now, so let's check the other things. So we've got Rsvp working now. I believe I checked BGP already, but we can check that again. Oops. So nope. We've got that down. Yeah. Before that, so Ospf is going to be up because yep, Rsvp was up. Before we check BGP though, let's check the MPLS LSP. Okay, so that's down. Let's troubleshoot BGP first. So here's the neighbor. This is the IGP that is down. IBGP that is down. The IGP is Ospf and that is up. So it looks like the problem is we don't have a route to the host. I also don't see. Yeah, I don't see a local address defined. which we're probably going to need for IGP. If I go back and look at the other autonomous system, show configuration routing, or show configuration pipe display set. We do have loopbacks here, so it looks like I just missed the loopback configuration, so I will add that. Yep, so you can see there's no loopback configuration. Let's go ahead and add it. /32, because that's the neighbor address. Before we commit, let's go back into BGP. Okay, so we do have a local address here. Oops, and it looks like I configured this with the wrong address. It's meant to be configured with this local address here. So let's fix that. Okay, so we're going to have the local address be this /32 instead, and then the loopback address on the other side is going to be .173. Perfect. So now hopefully the BGP neighborship is up. Oops, so it's still inactive. Let's see if I can ping it. Yep, so I can ping it now, so that's good. And it might just take a little bit of time for it to come up. Let's do a clear BGP neighbors. We're in the lab. Might as well. On test day, I can do this too. Wouldn't really want to do this. Well, even in production, if it's just, well, I'd be careful with it. But yeah, let's do, so yeah, and then by the time that second one is up, I think that'll be more than enough time for that first one. So we'll just keep an eye on that. Yeah, it looks like, unfortunately, it's taking a long time to come up. Yeah, that might not have been the best idea to clear those neighbors out. But the interesting thing is it actually looks like, oh, here we go. Okay, yeah, so it just took quite a bit of time. Yep, we're all open confirmed, so we're on our way to establish. We're there. Yeah, so everything now looks good. Let's take a look at the MPLS LSP. MPLS LSP is up. We've got an ingress and an egress that are both up. Okay, so we've got two more to check. This is the final one is not going to be as complicated as this one, so this is the kind of the last one in some sense. So let's take a look at the Rsvp neighbors. Rsvp neighbors are all up. It looks like we have an extra neighbor. I'm not sure what that is about. Yeah, I'm not sure why there's an extra. Oh, you know why there's an extra neighbor? It's the okay, yeah, I guess I'm not sure why there's a extra Rsvp neighbor. I wanted to say that it's got a neighborship now with router B, but that's not going to be the case. It's not going to form a neighbor like with router D, with router B. Okay, so let's look at the other protocols. So let's verify Ospf. Now, I'm doing this a bit out of order because ISIS is dependent on an OSPF neighborship. Really, the correct order to verify is to ping everything, verify OSPF neighborships, then verify Rsvp. But if you do it in reverse order, you can kind of like verifying OSPF first. Yeah, I guess maybe perhaps I would be better served by doing it in the proper order. All right, so the IBGP connection is up. It looks like there's issues with the eBGP connection. Okay, so let's troubleshoot that. We're going to log into RudderF and take a look. So the local autonomous system here is 10045. Okay, so it looks like we got a bit of a problem here. The autonomous system is 9, but our autonomous system in the statement here that forms the eBGP connection is specified as 11. So easy problem with an easy solution. Alright, so now hopefully that BGP neighborship will come up. I'm going to do a pipe refresh 1. Now, it did take quite a bit of time in the last one. I'm sure it's configurable, or I'm sure it's a certain amount of time, and you can probably even configure it, but I guess I'm satisfied to wait. I'm not sure how long to wait before believing that it's just not going to come up. One thing I haven't checked is the IP addressing. So, oops. Okay, so yeah, I would be sitting here waiting forever. It looks like I don't even have an IP address on GE000. Okay, so obviously that's going to be required. Let's set that up. Okay, and we're going to do set address. So this is a eBGP connection, so it's going to be specified in the configuration here. Okay, so here's the address, /30. Okay, so then the other side is going to be .13. And I think the other side, nope, the other side hasn't been configured yet either. Oops, so it looks like it went back into active when it went to open send. So clearly there's bigger issues at play here. So I'm going to do a Control-C and do some step-by-step troubleshooting. So first step I'm going to do is ping the other side, .14. So we've got no route to host. Okay, well that's interesting. Why do we got no route to host? No route to host. Is there no 192.168.198.14? So this is interesting. It's not showing up in the routing table at all. So really good news here. The forwarding plane is functioning properly. That was a big concern I was having. Yep, good news. On the other side, it's functioning properly as well. Oh, okay, I do have a local route. But yet I can't ping my local route. That's interesting. I guess I'm tempted to just throw family MPLS on there. I don't think it has to be on there. I guess instead of that, let me do something that might be a bit more intelligent. I'm going to compare it to router B. Okay, so I'll do a full compare. I'll put them side by side in Notepad++. Okay. Okay, so it looks like we do have some extra lines here for router B, so we're missing 2 lines from, it looks like we're only missing 1 line from router E. Looks like 2 for some reason. Oh, yeah, it is 2. We're missing lines 38 and 39. So let's take a look. Yeah, so I don't have, okay, so we're missing 2 lines because we've got descriptions here. So yeah, I'm not going to need family MPLS on that other side. And this is definitely the customer facing, I think. Yeah, GE's 001 is the customer facing, so yep, it's got the same kind of configuration. And then the core facing. Okay, so let's add extra space, extra new lines here, just to simulate those descriptions so that it lines up. It's easier to verify. So taking a look at the import policy. Okay, the reason I looked at that is because I wasn't able to ping myself, so I was wondering if there was something wrong with importing the routes. Yeah, everything looks pretty good. I can't think of what would be the problem. Yeah, so everything looks good. Let's pull up the other the config here. Yeah, everything looks good. So I'm wondering if it just needed some time to come up. Maybe it's up now. I'll take a look. Ah, so yep, it looks like it just needed a bit of time to come up. Perfect. So yeah, it's up on both sides now. It just takes longer than I thought it would take. Okay, so the final test will be pinging from end to end for those both of those CEs. So I should be able to ping a loopback on router A all the way from a loopback on router F. Okay, we'll do it vice versa. We'll ping from router A to router F. Okay, so we'll do 10.10.10.1/32. Okay, and then we'll do .2/32 on the other side. Okay, so now let's see if we can ping end to end. Oops, don't need the subnet mask. Ah, so it looks like we've got no route to host. Okay, so it's time for some more troubleshooting. Now we should have a BGP policy that was sending all of the directly connected routes. Yep, so from protocol direct, we should be, so this is a directly connected route, so we should be sending that route. So let's verify that. So show route advertising protocol, BGP, and then 192.168.198.2. So yes, we are advertising the loopback address. Let's see what happened to it on router F. Or let's see if we received it on router F. Okay, so we didn't receive any routes from router F. Let's take a look at router C, make sure we're advertising it to the other ISP. Okay, so yep, it looks like we are advertising it. We're advertising it as a special BGP L3 VPN route, but we're certainly advertising it. Let's make sure that router D is receiving it. Okay, so here's the problem. Router D is not receiving that route advertised from router C. Now the configurations on router C and router D should be pretty similar, so let's put them side by side. Okay, and time for the configurations on router D. Okay, so we've got the same number of lines. That's really encouraging. We've got quite a few differences though. It looks like on router C we've got 4 lines of config for IBGP and 3 lines of config for EBGP, but on router D we've got 3 lines of config for IBGP and 4 lines of config for EBGP. So let's see what the extra IBGP line is. So we've got neighbor, we've got family. Yep, we've got neighbor, we've got family, we've got type internal. But we're missing local address. So let's set the local address statement just so that the configs are more clear. This is on router D, so we're going to edit protocols BGP, and then it's going to be IBGP. Oops, it's going to be group. Yep. Set local address, and it's going to be the address of the loopback. Perfect. Okay, so now it should be more clear what the differences are, now that there's more similarities. Oh, so we've got an extra line for eBGP now. So first one, we've got type external, family, and neighbor. Here we've got type externally, external, family, and neighbor, but we've also got peer AS. So here we've just got it on the same line as neighbor. Yeah, you know what, let's clean that up, make that easier to read. Perfect. Okay, so commit and quit. Now, yep, there shouldn't be the same differences. Oops. Perfect. Okay, so yep, everything looks good. Oops, I accidentally hit the wrong button. Still hit the wrong button. Okay, there we go. That's the right button. Yeah, so now, yep, now we've got the same number of lines. We've still got some differences. It looks like they're named different. We've got different, yeah, but like other than that, everything seems to be pretty good. I don't see any other major differences really. So yeah, I'm kind of stumped on some level as to why we don't have anything received on router D, even though we did verify that it's being sent on router C. So that might be a good logical conclusion, is that question: why is router C advertising a route, but it's not being received by router D? That might be the good question to stop on. So show route receive protocol BGP, and then it's going to belong to .21. Yeah, so you can see very clearly it is sending a prefix, but it is unable to receive that prefix. Okay, so that's what's going to be the next video. I'll be figuring that out, hopefully solving it, and then if I can solve that, we'll do the next example in the help apropos of Interprovider VPNs, and then move on as soon as possible. So thanks for watching, and I'll see you in the next one.